Okay, so our first speaker of the night is no other than the amazing Tom Nom Nom. He is, I'm very, very happy to know him personally as a friend. He is a member of Team Disturbance and provides some really cool stuff to Detectify. Bring it up for Bash Hero Vim Master Tom Nom Nom.
Hi, I'm Tom Num Num, and this is Who, What, Where, When Wordlist. Really, it's a talk about word lists. So I think a pretty good place to start off, or at least as good a place as any, is what is a word list? And it's a list of words, and yeah, I am being a little bit silly there, but it's a list of words used for brute forcing. Maybe I'm actually using that term a little bit incorrectly. Maybe a better way to be putting it would be it's a list of words used for guessing things instead. So word lists are useful if you want to check all the combinations for something, but we don't really have enough time to do that. So with a little bit of quick maths, we can figure out that if somehow you manage to maintain 500 requests a second and you wanted to get all 6-character directory names in like a path brute force with some tool like Dirbuster or Fuff, however you want to pronounce it. Things that match this set: lowercase letters, uppercase letters, underscore, and dashes, 6 characters long. You're looking at more than 4 years to brute force all of those possibilities. And that would be the ideal way to do things in theory, because you would definitely find everything in that set. Except you're gonna firstly take too long. Secondly, you're gonna fill a server's disk up with logs, and it's probably going to crash, and it's just not practical. So really, word lists, as far as I'm concerned, are something that exists to save time and resources, to make attacks a bit more practical. They can be used in a lot of different places or a lot of different ways. So probably one of the most common that you're probably familiar with is subdomain enumeration. So guessing which subdomains exist for a particular apex domain, like target.com or yahoo.com. Also, path guessing, an incredibly common technique to do. So we already mentioned that, using tools like Dirbuster or Fuff. But also, authentication guessing is kind of one of the oldest use cases for this sort of thing. So guessing usernames and passwords. More recently, I've found myself using it to guess API method names, for example, in an RPC style API. If I've got no documentation, I don't know any of the API methods, guessing might be a good way to go about it. Other parameters, so query string parameters, post parameters, or headers, I guess, should probably be included in parameters as well. Any kind of input that the application accepts but isn't documented, I want to get those things. So you probably get the point. So one of the places you can get word list from is the internet. And there's a few that are very popular and with good reason. So Seclists is probably, I would say, the most used among bug bounty hunters, if I had to guess. It's well organized into different categories depending on what you want to use the word list for. And there's a lot of coverage as well, so really good lists. Quite recently, Google have released some of their fuzzing dictionaries. I've been playing with those a little bit. They seem to be quite good. They're much smaller, and often I find they're not quite in the right format that I want, so I have to mess around with a little bit. And if you go Googling, there are many, many more on the internet, depending on what your use case is. So, for example, CrackStation have a fantastic word list, and it gets many, many gigabytes of possibilities. And also, sometimes you only need something simple. So, user share dict words is a dictionary file that exists on many Linux distributions, and sometimes that's all you need. So, what's the problem with those word lists? And really, the main thing is despite being genuinely useful and being awesome in the case of sec lists and so on, like I said already, everybody uses them. So if you are running the same word list as everybody else, you're going to find the same things as everybody else. And that means, maybe you'll get duped, or maybe it's just that you'll be looking at things that have already been tested quite heavily by other people. There may well still be bugs there, but if you're trying to increase your chances, maybe that's not what you want. They're also generally pretty generic. So most applications have many paths or properties or parameters that are specific to them, that don't really show up so much in other applications. And that means they're less likely to show up in these generic word lists. They're also often really large, so we're trying to save time and resources. And if you take sec lists, for example, there's about 1 gigabyte of text in there. And it's going to take quite a long time to chew through all of them. That's a bit unrealistic perhaps, because you wouldn't usually be using all of them, but the point stands. Because they are generic and because they try to cover as many cases as possible, they tend to be very large and sometimes impractically so. So I think if you're going to find things that other people aren't finding and you're going to be efficient, one of the best things you can do is build custom word lists. So, like we said, every target has something specific to them. Generic word lists probably won't contain target name _ super happy API docs. It might do, but it's pretty unlikely. And if that's the directory that happens to contain the secrets that you need to exploit your bug or finish your exploit chain or whatever it is, or even just to find a bug in the first place, it would be really useful to find out about them. Also, there are specific use cases which I think call for specific word lists. So my example here is, no point using a subdomain list when you're guessing headers. So those lists that you need might exist already, but if your use case is very specific, it becomes quite unlikely, and you have to really look at building your own. So one of the easiest ways to do that is to have a manually curated list. And I would say the word list that I use the most is one that I typed out myself. It's not very big. I think it has maybe 200 entries in it or so, but it has been very, very useful. It's made me a reasonable amount of money over the couple of years that I've been putting it together. And I just add to it when I read something interesting. So if that's a disclosed issue where there was a particular path that was mentioned, or maybe it's just a blog post about some interesting files that someone's found or something like that, I'll just add to it. But I try to keep the quality high and the size small so that I can use it quickly. One of the most powerful things, though, I think, when bug hunting is to have a target specific list. So rather than one of these generic lists with lots of entries that are almost definitely not going to exist. So for example, if you're looking at an Apache server running mod PHP, there's no point looking for all those .aspx files because they're almost certainly not going to exist. Almost certainly. So let's take a look at an example of building like a path guessing word list for a specific target as an example. So we're going to need a need, which in this case is, we want to guess what directories or paths exist on a web server. We're going to need a source of data, somewhere to actually get the information we need to build our word list. We need a way to process the data, so depending on where we get it from, the data might not be in the format that we require. So we need a way to process it. And then we need a way to use the word list, which is kind of mostly outside the scope of this talk, but we'll pay a very small amount of attention to it anyway. So first off, where are we going to get path data from? We want lots and lots of URLs specific to the target that we can extract the data from. And a really good, nice, easy source of that is in your Burp Suite history. Everything that's been proxied through your Burp Suite project has been saved. It's in the target tab. In the sitemap, you can right-click a host, click copy URLs in this host, and you've got a list of URLs. That's a really nice source of things. Google Docs are also really handy for this, but they can be a little bit tedious if you're sort of copy and pasting everything. Google generally do not like people scraping their search results, but I have a little trick to make it not automated, but a little bit easier, which I'll show you in a minute. There's tools like GAU or Get All URLs, which fetch URLs for a particular domain from the Wayback Machine, VirusTotal, and a bunch of other services. I may have also written a tool myself that does this too, but I thought I'd give someone else some credit for a change. Sitemaps also, you find a sitemap.xml for a particular domain. That's going to tell you actually quite a lot about what's there. And one thing I want to point out is remember to include paths from all of your target's domains. So sometimes a boring path on one domain might actually be quite interesting on another. And what I mean by that is, some companies will have different applications running on different domains, but running out of the same code base. So the code base can run more than one application. And sometimes you'll find that a path which is totally innocuous and does what it's supposed to on one domain isn't quite configured right to run on a different domain, but still responds. Maybe it gives you errors, or maybe there's some checking missing or something like that. But the other thing there is, if we're fetching URLs from Wayback Machine, it might be the case that a path is only known about on one particular subdomain and is interesting there, but exists everywhere. So, we want to have a look in all of the different places that we can. And I mentioned Google Docking and how it was a little bit of a pain. So I want to show you something that I hacked together to try and make it a little bit easier. So you are probably familiar with Google Docs like this one. So let's look for everything on yahoo.com that has an extension of PHP. And why not? And straight away, I've got an I'm not a robot thing. And this is the problem with trying to automate this kind of searches, is you're going to hit these captchas or I'm not a robot tick boxes all the time. And it's really hard to script. So what I could do is sort of go through all of these results and open them up in new tabs or something, copy the URLs, but that would take a really, really long time. So what I built was this little extension. I called it Web Paste. It lives in my hacks repo. There's no real documentation to speak of, so I think if you want to use it, you need to be willing to put at least a little bit of effort in. Even if it was documented, to be honest, I think you need to still put a bit of effort in. But what it does is it provides this list of buttons, and I'll show you the configuration for these in a moment. And one of them says Google URLs, and right now it won't do anything. What I need to do is run a companion app called Web Paste in my command line. And you can see it's not actually doing anything right now. But if I go back to my Google search, click the Web Paste icon up the top, click Google URLs, you can see it's moved to the next page. But what it actually did was extract all of the URLs from that search page, send them to the companion application, which is actually a little web server, and then move to the next page of the results. So the end result is I can sit here with this menu open, clicking this button, moving to the next page really easily. And if I get any of those I am not a robot prompts, I can deal with them and click all of the images that contain fire hydrants and be on my way without having to worry about being like breaking Google's terms of service or anything, which I don't think I'm doing, because I'm still a human. I'm just clicking a button. I'm just saving myself a little bit of time. So we can see all of those URLs appeared in this list, and that's great and all. But from here we could either copy and paste them, or we could have put them into a file in the first place by running something like web paste, say t-a docs.txt or something like that. So if we go back to the browser, click our button a few times, we'll see that there's some URLs come through, and they also exist in that docs.txt as well. So we can then use them for whatever we want. So I'll just show you a little bit of the configuration of this web paste extension so you can get an idea of how it does what it does. So if we right click it and go to the options, we'll see firstly that I am not a graphic designer in any way, shape or form, and secondly there's a couple of bits of configuration up the top, one of which is a server, which is where that little web paste companion app is going to be running, and it defaults to port 8080, but you can change it if you want to. And also there's a token which is completely arbitrary, and it has to be exported in the terminal as well that you're running the companion app in, so they have to match. And the reason for that is that I guess it's effectively standing in for some kind of authentication mechanism between the extension and the web paste companion app. So you could run this on a VPS or something like that if you wanted to. So each one of these snippets is not something that's bundled with the extension, but what it really is a name and then a couple of pieces of JavaScript. So it said here the code should return an array of strings. So if I move back to my Google tab over here and pull up on a console, and I run this bit of JavaScript, you can see what we get back is an array of URLs. So we're using a query selector with the CSS selector to find the anchor tags in the Google search results that have the hrefs that we want, and we're using a map over those to extract the href attribute, which is where the URL is. The second bit of this though is what happens when that has succeeded and run. So this is the part that we can use to move to the next page of results, so we don't have to do it manually. So in this case it's fairly simple. We set document.location to the value of the next link. So if I paste that into the console over here, we should see we're currently page 10 of results, and when I paste it we move on to page 11. So that's all it's really doing, is the array of strings that's returned here gets sent to that companion app, and then you can do whatever you want with it. I have a few of these set up for doing different kinds of docs. So one to extract the GitHub repo URLs from lists of GitHub search results, one to pull out strings from the beautified JS source code from the JS beautifier extension that I use, one to pull out clone URLs for results on software heritage, IPs from census results, and the scope from HackerOne profile pages as well. And sooner or later these are going to break, but they work quite well and they're relatively easy to maintain. So, but for Google Docking, especially for building word lists from these results, I found it to be incredibly useful. So now that we've got a load of path data, or actually we've got a load of URLs, we need to process it somehow. I don't want the full URLs with the domain on attached and that sort of thing. And a lot of the time I probably don't want the query string either, or any page fragments or anything like that. So here in this example, using Go to fetch URLs for example.net, and I'm using a tool of mine called Unfurl, which I think is probably one of the tools that I use the most out of the tools I've written. It's certainly one that I'm very happy with the name of. I'm actually quite proud of myself for that one. So what this command here means is use Go to fetch URLs for example.net, and then pipe, or take the output of this command and feed it to the input of the unfurl command. We have the -u flag, which means only produce unique results, and then a parameter to say I actually want the paths part of the URL. So there are other options too, which I'll show you in a sec, but this gives us all of the unique paths from all of those URLs. And we could just use those as our word list if we wanted to, and it would be relatively fast if we did that, but I think we would miss things as well. So, you know, not everything that exists on these domains is going to be in those archives, and maybe a better idea would be to split them apart. So you can see we have here ~Susan/wiki, and you know, that might not exist, but some other directory /wiki might exist. So actually we want to pull them apart, and I'm doing that here with sed. So sed is the stream editor, or text stream editor, and here I've just given it a regular expression to say search for a pattern, which is the part between the first two hashes, which is just a /, and replace it with a new line character. And then this hash is the end of the pattern, and the G is for global. So if it appears more than once on a line, both will be replaced. By default, only the first one's replaced. And as an input to that, we use the paths.txt, which is just the saved output of the previous one. And because there's going to be lots of duplicates in there, so we know, ~Susan appears lots of times here, ~user appears lots of times here, we use sort-u, which sorts the output and removes the duplicates. Only gives you the unique outputs. So we remove all of the duplicates that way. And like I said, then we want to recombine them recursively somehow using your tool of choice. So here you would want to look for /me, but also /media, and then also /me/member.php and /media.member.php, and so on and so forth. So while we're here, Unfurl has a few more tricks up its sleeve for other kinds of word lists that you might be building. So you can also pull out the query string keys and the values, or you might call them the parameter names, I guess. I went with keys when I built the tool. The domains, also portions of the domains, like the top level fragment, the subdomain part, the fragments, the ports, and generally it's pretty flexible. There's a format option, so you can have effectively a custom output format for it as well. If you deal with big text files full of URLs quite often, I think you'll find it quite useful. So now that we've got a list, we want to use it. And we have a lot of options here. So people would use dirbuster, gobuster, many other things that end in buster. And you probably already have a favorite. But if you don't, fuff is good, or fuff. I'm not quite sure on what the official pronunciation is. Burp Suite's Intruder and Turbo Intruder are both very good, especially if you need a great deal of control over the request and you maybe want to be changing more than one thing at once, or maybe you want to be using Hackverter or something to apply certain encodings to things. That's very useful. And then I have a few tools of my own too. So I have Meg, which has been around for quite a while, and has some shortcomings, but I think is still useful. Concurl, which is designed for running curl in parallel or concurrently, hence the name. And then something I've been playing with more recently called FFF, which stands for the Fairly Fast Fetcher. And I apologize for the name of that and how close it is to Fuff, but I think I named it before I was familiar with Fuff, and it's just kind of stuck with me, and I haven't thought of another name for it yet, but we'll see it in action later on anyway. So here's an example of using Fuff or Fuff, and the usage is pretty simple. So we give it a word list with -w, so this is our paths.txt that we created previously, and then some URL to use. So we have example.net/fuzz in all capital letters, and this fuzz will be replaced with each line of the paths.txt in turn. And then you can change the filtering options of what it responds to and all that sort of thing as well. And for the record, it's significantly more powerful than that, has a lot more options. You should definitely look into how it works and what it can do. So, that was all useful, but we're still sort of only finding things that are already known, I guess. They were found by the Wayback Machine at some point. If that's the source we're using, or they were already found and were in your Burp Suite history. But to find things that are perhaps not linked but may exist, and we still want a list that's quite specific to a target, one of the techniques I've come up with is a way to get a list of words that are at least more likely to be unique to a target. So if I fetch, for example, just the home page of a website, there's going to be a lot of words there that are really definitely not specific to a target, like basic English words for one. Also HTML tags, things like body or div, for example, are going to show up in basically every web page, and I don't necessarily want to be searching for those. So one of the things that you can do is use a second completely unrelated source of data to sort of remove a lot of those common words. So here, as an example, I'm using the HTML RFC because I know it's going to include all of the tag names that are in use and a lot of other technical jargon that might show up in source code that in this case I don't really care about. So here I've used curl to fetch two files, HTML RFC 1866, and I've stored that in rfc.html, and then the Yahoo UK homepage, which I'm storing in yahoo.html. So the next thing we need to do is what's called tokenization, or at least that's what I'm calling it. Really, we want to extract all of the words from those files without caring about special characters, and quotes, and less than and greater than, all of those things that show up in HTML source. So I have a silly sort of alpha quality tool for doing this called Tok. You just send it text to its input with a pipe, and it outputs words that appear. It doesn't remove duplicates or anything like that. It reads 1 byte at a time, and when it hits a non-word character, it spits out the word it's been accumulating and moves on to the next one. You can give it a list of characters that it should accept. So by default it doesn't accept dashes and dots, for example, but you can force it to do that if you're looking for candidates for domain name brute forcing, or guessing I should say, for example. Or you can use grep with some creative regexes, or do whatever you like, but I'm using Tok here in this example. And a very important prerequisite here is I want to do some normalization and sorting on these lists of words. So I'm going to use duplicates, remove duplicates, should I say, sorry, with sort-u. And in this case, and this isn't necessary, but I'm using tr or translate to move change letters in the class of uppercase to the class of lowercase. So I'm applying that lowercase transformation. And again, depending on your use case, you may or may not want to do that. But otherwise, I'm extracting the words, I'm sorting them so that both lists are sorted. And the reason we're doing that is because the tool that we're going to use is called com, requires that those lists be sorted. So the com tool compares sorted files and tells you which lines are unique in each file, and by default you get 3 columns of output, and this is a part of the reason that the options for it are a little bit confusing, I think. So this is part of the man page from the com utility, and we can see there's column 1s, 2 and 3, where 1 is lines unique to file 1, 2 is lines unique to file 2, so that would be RFC words and Yahoo words respectively, and 3 is lines that appear in both files. And in this case I only care about the words in column 2, so I'm going to suppress columns 1 and 3 with -1, -3, which can be combined. So you can see here we get some quite Yahoo specific looking terminology appearing in this list. And actually off the side of this screenshot there's a head and a tail command to sort of give us a window somewhere into the middle of the list that looked a bit more interesting, but the point still stands. that we've ignored a lot of the generic words that we don't care about, and use that to try and zero in on the things that are specific to the target, and that may prove to be more useful in a variety of situations, including path guessing. So, that was with just one HTML page, but, in reality, most sites have more than one HTML page. We might want to fetch lots of them. So you can use tools like Meg to do that. It does a fairly good job of that. Or you can just, write a bash script, use curl. You can use wget with its mirroring function, anything like that. But one of the things I found to be really useful, especially for parameter guessing, API name guessing, and that sort of thing, is JavaScript files. So one of the things I've found myself doing from time to time is wanting to fetch the JavaScript files associated with web pages. And it turns out to not be super trivial to do. I've been doing some experiments of using headless Chrome to do it, but they're not quite finished yet. So I might talk more about those in the future. But for now, kind of a relatively low tech way you can do this is to fetch lots of pages for a site. So here we're using Go to fetch URLs for yahoo.com. And we're just going to take 1,000 of them. I don't want to request too many. And I'm going to use my FFF tool, the fairly fast fetcher. And what these options mean is I want to save responses with the 200 response code and also those with the 404 response code and store them in a directory called Yahoo. And that's all it means. And then I'm going to use the find command to list all of the files, things with type -f, in the Yahoo directory that have a name of star.body. So FFF stores 2 files for each request, a .body file and a .headers file that contains the headers. And we're interested in the body file. And I'm going to pipe them to this little tool I wrote called HTML tool. And what that does is it extracts HTML, parses HTML, should I say, and extracts certain parts of it. So you can extract attributes with attribs, or you can extract tag contents with tags, and I think it does comments as well. So that can be quite useful in some situations. But here we're using the attribs src to return the value of the src or source attribute from all of the HTML tags it finds. And because that includes both script tags and image tags, in this case, I'm just using grep to say I only want the ones that end in .js. And I'm going to miss some here, and some of these will be relative paths that will need further processing, but at least some of them are going to be absolute paths that I can then pass back into FFF to fetch all of those JavaScript files, and then I can use the techniques like using toc or using grep to extract the pieces of information that I want for them. So I found that to be quite useful. And also, don't forget to grep them for secrets and all of that juicy stuff too. So another thing that I think could be really useful, but is a little bit different, is lists that are custom, but still a little bit generic. So a lot of people like to hunt on more than one target at once, myself included. And it'd still be nice to have good word lists, and preferably ones that maybe include some things that those public lists don't, so that you can be finding some things that other people don't. And also, sometimes you want to just look for like a specific vulnerability. Maybe you just found a 0-day in something and you want information to build a word list to go off and look for it in lots of places. Those things are, legitimate use cases that often those generic pre-baked word lists don't necessarily cover. So one of the tools that I've found myself using quite often to build these kinds of word lists is Google BigQuery. And straight off the bat, I need to give you a bit of a warning here. Some of these things in the next slides can cost you not insignificant amounts of money. So BigQuery costs about, I think it's $5 per terabyte to query. And depending on what you're querying, you can go through multiple terabytes quite quickly. there is a free tier which gives you about, I think it's about $300 of credit in your first year. I've long since used mine, and I think your first terabyte per month is free. But outside of that, do be careful. But what there is also on BigQuery is some really useful data sets. So one of them is in BigQuery public data. It's the GitHub repos data set, which contains quite a lot. It's a little bit outdated, but still very useful information about lots and lots of GitHub repos, including the file contents, the file names, all kinds of useful things. There is an HTTP archive dataset on there as well from the Wayback Machine. I'm not sure how up to date it is, but I can tell you it's very, very large. The tables I was looking at recently were approaching 10 terabytes. So if you queried a significant fraction of them, you'd be looking at $30, $40, maybe $50 per query. So do be careful. And use the sample tables to get your queries right before you commit to running them, and then hopefully maybe they'll make you your money back afterwards. So one of the first things you can do is you can use the GitHub repos data to find paths for files based on their contents. And here, as an example, I'm looking for potential files that contain the PHP info command. So that's one of the things that always makes me smile on a target, is when I see a PHP info page flash up. So I thought it would be a good idea to try and figure out what paths I should be looking at when I'm looking for PHP info files. So if you're not familiar with SQL, don't worry too much. But what this query does is it looks for the path, which is the part that I'm interested in. So select path from the contents table or contents data set in the GitHub repos database. And I'm joining the files database. And the way they're linked together is that the ID field is the same. So this is maybe feels a little bit backwards actually. It should be select path from the files table, because that's the one the path field exists in, but it doesn't matter, it works either way. So in the join, what we say is how these tables relate to each other, which is that the files table and the contents table both have this file ID field and they match up. And then we use the regexp contains function to pass the content from the contents table and look for PHP info in the file. And this is just an example. You could look for whatever it is you're looking for. But what I get back from this is a big old list of paths of PHP files that contain PHP info. And again, there's going to be false positives in there, but there's going to be true positives as well, and things that are really good to know. What I would say about this technique is it's relatively expensive. So BigQuery helpfully tells you how many terabytes of data you're going to process by running this query. And in this case, it's 2.5, which I guess makes it just a little less than about $15 to run, depending on the region that you're running in. So in the global region, I guess, I believe it's $5 per terabyte. So, not a cheap query to run. So hopefully you get at least a $50 bug out of it to pay for it, or maybe you're using your free credits. The other piece of advice I would give you is to use the save to Google Drive option, and I use the CSV because it's easier to process than the JSON files. I think multiple sort of hundreds of megabytes of JSON files is quite difficult to deal with. Even if you're using some very good open source tools for dealing with JSON files. Save to Drive gives you the option to get up to 1 gigabyte of results, whereas I think the download option is only up to 16,000 rows, which is probably a lot smaller than 1 gigabyte in this case. So that's a useful approach. Something that's a bit cheaper though is to use the paths that you kind of know at least a little bit of to find things instead. So I've used this technique for a few different things, but the one I want to show you an example of is looking for Nginx config files. So you might be familiar with an Nginx misconfiguration that's become known as off by slash, where it allows directory traversal. So in order to build a word list for that, I want a whole load of Nginx config files. So all I'm going to do is say select the repository name and the path from the files table, where the path is anything like nginx.conf. So these percents are wildcards. So if nginx appears anywhere in the path and it's a .conf file, then it's going to show up in the results. And again, there's going to be files in here that aren't actually Nginx config files, but as long as I'm prepared to deal with that bit of noise, it's okay. So if you're not familiar with this particular issue, this is a slide from Orange Side's fantastic presentation, Breaking Parser Logic, which was presented at, I think, Black Hat 2018. And it's a wonderful find. And this is what it looks like. So this is a bit of Nginx configuration, which says for the location/static, actually we want files to be served out of this location. And the problem here, and why this is called off by slash, is this location block does not end with a slash. And that means it matches this URL here with the ... and everything after the static gets appended to the real path like this, which allows path traversal. So this is what we're looking for, this slash static. I want as many of the possible locations for this as possible. So I run my query and I've ended up with a results file that looks like this. So this is my CSV file of the repo name and the path. I'll want to remove that first line before I do any processing. And then I have the repo name and the complete path. So here we've got this repo whitlocks/DCS, and then within that the path is controller/nginx.conf. And I want to go and fetch those files somehow, but one option would be to go and clone all of these repositories, but with thousands of repositories, when I don't even want to see most of the data, that's a real waste of resources. But as luck would have it, you can fetch them directly from raw.githubusercontent.com. So when you're viewing a file on GitHub, when you click the raw view button, this is where the file is loaded from to show it in your browser. So I would say please use rate limiting. Be nice to GitHub. Even though you're sort of technically saving them resources by not cloning tens of thousands of repositories, still be nice to them. So here I'm using awk, using -big F to say the field separator is a comma, and I want to print out the URL https://raw.githubusercontent.com/$1, which is the repository, and then /master, which is the default branch name in Git, /$2, which is the path to the file. And then I use the nginx files.csv as the input. So that will give me a list of URLs that I can fetch that will contain all of those nginx config files. So I'll save them in nginx-urls.txt, mostly because the line length's getting a little bit long, and then I can use FFF to go and fetch them using the -d or delay flag to apply some rate limiting. Once we've got them though, we need to process them somehow, and ideally we would use like an actual parser that understands the grammar and syntax of nginx config files, but that sounds quite difficult. So here I'm going to kind of hack it with grep and awk instead. And for my purposes, it doesn't have to be perfect. I'm going to miss some of these paths. That's okay. I don't mind. I just want a half decent list that's going to increase my chances of finding something interesting. So here I'm using grep with H to suppress the file name in the output, R to look recursively, and I to look in case insensitively for the word alias in this nginx configs directory where we stored all of the files that we fetched. And I'm using a relatively uncommon flag for grep here, which is the big B3, which means provide 3 lines of context before the result. So my guess basically is that it's going to look something like this. So there'll be the word alias, and if I get a few lines before that, it will probably also include the location block too. And then from that output, I'm going to regrep case insensitively, only include the matching part of the output with extended regular expressions for the location part. And I'm looking for things that look like regular paths. So something's A to Z, 0 to 9, / dot, underscore and dash, that do not end in a slash. So it's one or more characters that match that set, and then one character that does not match /, followed by a space and then the curly bracket at the end. So that should find me all of these location blocks which contained an alias and did not end in a slash, which should be vulnerable to this off by slash issue. So usually when you do this kind of thing, you still end up having to do a bit of data cleaning. So, you know, here I've still got the location part and the slash and the curly brace and things. So I would say, you know, simple shell tools like awk, or grep, sed, if you're familiar with them, or if you want an excuse to learn them, are really useful for doing this kind of thing. But, you know, don't be afraid to do things manually in your editor, to manually review the list, scroll through it. Even, you know, if it's 1,000 lines long, that feels long, but really, you know, it's only going to take you 5 minutes to scroll through, maybe pull out things that don't look right, or manually fix things, or whatever. Or maybe even see things that you want to manually apply some extra conditions to, and duplicate and modify slightly. There's more files than just, you know, the nginx config file that this sort of technique would be useful for. Here's just a few that you could use. So robots.txt contains paths, and, you know, some of which are disallowed and should not be crawled by search engines. That aren't going to, so they're not going to show up in Google Docs. I reckon if you pulled all the robots.txt files on GitHub, or at least a decent sample size of them, you'd probably find some interesting paths in there. .gitignore files, again, these are sort of files that, you know, by definition, the files listed in there should probably not be exposed on a web server. So it's kind of an interesting source of path names. Make files, rake files, those kinds of configuration files in general often contain lots of paths to potentially interesting files. So that's it from me. So you know, a big thank you for listening if you made it this far. And really, I think the important things to remember are keep a manually curated list for the really interesting things that you read about. So have that sort of small, fast list, but also, you know, target specific lists are going to help you discover things that generic word lists ordinarily cannot. Google Docking is fun. If you're feeling brave, maybe have a play with that Chrome extension I put together, and also set billing limits in BigQuery. Because otherwise you can have a really bad time. Most of all, stay safe, have fun. Thanks.